Well, last night's Monday night's homework was page 163, 2 to 10, except 5 and 9. Right, okay. Anyone need me to do number 2? Sorry? Why is that now? Because I'm on freeze. Right, thank you. I'm still on freeze. Is it off? Okay. Okay, right. Okay, eventually. Right, so number 2, number 3, number 4, number 6. Yeah, number 6. Right, okay. Verify that the line 3x minus y minus 4 equals 0 contains the point 2, 2. So that's everywhere you see an x, put in a 2. Everywhere you see a y, put in a 2. So you get 3 times 2 minus 4 equals 0. You get 0 equals 0. That's a true statement, so that means 2, 2 is on the line. Okay, is that alright? Yeah, what's going on here now is, wait now till I see, I think if I turn this off, and if I turn it on again, I think it comes back the way it's supposed to be. It's gonna blow. It's gonna blow. Come on. Yeah, it's better. Right, okay. I hope it's going to brighten up. It is. Right, okay, so hence find the shortest distance between 3x minus y. So this is one line equals 0, and this is the other line, which is 6x minus 2y plus 7 equals 0. They are parallel, right? Okay, so the distance between parallel lines, girls, is you pick a point on one line and you get the perpendicular distance to another line, and that's the shortest point. How do I know they're parallel? Because they have the same slopes, right? The slope of this one is minus a over b.
Excuse me, please, if the head girls could come to reception now. Again, the head girls to reception.
The slope of this one is minus a over b. So that's plus 3, and this is plus 3. So they are parallel lines. So did they tell me they were parallel? They did tell me they were parallel, but I've just proved they're parallel anyway. The shortest distance between parallel lines, girls, is the perpendicular distance. So all you have to do is pick a point. Now they told me a point, but sometimes they don't tell you a point and you just pick a random point. Right? Okay, not a random point, a point that's on the line, obviously. Right? So you pick a point and get the perpendicular distance to the line. Okay, so I want to get the perpendicular distance from 2, 2, which is on this line, to the line 6x minus 2y plus 7 equals 0. Is that okay? So that's the shortest distance is the perpendicular distance, right? And if they're parallel, you just pick a point on one of the lines, okay? So filling in, that's 6 times 2 minus 2 times 2 plus 7 all over the square root of 6 to be squared plus minus 2 to be squared. Sorting that out on top, that's 12, 4, if that's 15, isn't it? 15 over that's 15 over the square root of 40. Okay. Now at the back of the book, they probably don't leave it like that, because you'd have a calculator and you put that into your calculator and press equals. Okay. But it's you're not supposed to leave a surge underneath the line. You're not supposed to have a surge in the denominator. Okay. So just to simplify that, you'd simplify it on your calculators, but just so you know where it's coming from, if you multiply above and below by root 40, you'll get rid of the surge underneath the line. So above the line you have 15 root 40, below the line root 40 by root 40 is just 40. Is that okay? Then we can I, yeah? Sorry.
Miss McHale bought you a pumpkin.
Oh, thanks. No, it's fine. I'll get it. Thanks. If it's food, if it was something else now, I wouldn't be able to pick it up. But food, definitely. Right, okay, so 15 over root 40, is that alright? So I can go 5 into 5 goes 3 times, 5 into 40 goes 8 times. So that's 3 root 40 over 8. There's even more simplification you can do. You can write that's 3, you can write root 40 as 4 by 10. Okay, all over 8. So that's 3 times root 4 times root 10 all over 8. So root 4 is 2. So I can go 2 into 2 goes 1, 2 into that goes 4 times. So I end up with 3 root 10 over 4. But as I say, calculator job. Okay, but that's where it comes from. Is that alright? Okay, but you wouldn't waste time doing that. But just in case, there's a lot of maths in that, like, so.
What does it say beside the 3 that you've crossed out?
That's a root 4. I crossed out root 4 and turned it into a 2, and then I cancelled 2 into 2 goes 1, 2 into 4 goes 8, or other way around, 2 into 2 goes 1, 2 into 8 goes 4 times. Is that right? Okay, that was number 6. 7.
Can you make your favorite number second?
Sorry. Do we need the other board?
Is that 3 and then square root?
3 root 4 root 10. That's 3 root 10 all over 4. Okay. Right, can I go? Right, 7. Anyone need 7?
Yeah.
Right. Investigate. Now that word investigate means it may or may not be. Verify means it is. Investigate means it may or may not be. So you have to get the distance from 1, 1, right, to equidistance means equal distance. Okay, so you want to know, is it the same distance from this line, where am I, x plus 7y minus 3 equals 0, and x minus y plus 1 equals 0. So you want to get the perpendicular distance from the point to both lines. Okay, and the question is it the same? Okay, so is it the same? So it's the square, the positive value, fill in for x, fill in for y, 1 for x, 1 for y, minus 3, all over the square root, sorry, that should be a straight line, all over the square root of a squared plus b squared. So a squared is 1, so 1 squared plus 7 squared. Okay, so simplifying that, that's 8, that's 5 over root 50. Right, I'm going to simplify that, that's 5 all over the square root of 25 by 2. So that would be 5 all over root 25 times root 2. So that's 5 all over 5 root 2, which is 5 into 5 goes once, which is 1 over root 2. So at this side I got 1 over root 2. Is that right? Calculator job. Okay? Right, you don't need to simplify it out by hand. Right? Okay, over this side, everywhere I see an x, put in a 1. Everywhere I see a y, put in a 1. Right? Okay, all over the square root of a squared plus b squared. A is a number in front of x, which is 1 to b squared. B is a number in front of y, which is minus 1 to b squared. So on top, you'll end up with 1. On the bottom, you'll end up with root 2. And the question was, investigate, are they the same? And the answer is yes, they are. Right, so investigate, it could have turned out no. Okay? Is that alright? 8, am I doing 8?
Yeah.
Right, okay. So 8, sorry, am I good to go? Yeah, right, number 8, so, right, the values of A, if the point minus 2, 3, so they're getting the perpendicular distance from minus 2, 3 to the line AX plus Y minus 7 equals 0, and the answer is going to be root 10. So you get the A times, instead of X put in a minus 2, instead of Y put in a 3, right, minus 7, right, all over the square root of a squared plus b squared. So a squared is a, so it's a squared plus b squared is 1 to b squared, right? And you know the answer is root 10. Okay, multiplying out on top, you get minus 2a, right, plus 3 minus 7 is minus 4, all over the square root of a squared plus b, or a squared plus 1 equals root 10. Okay, cross multiply. Okay, so I'm keeping the modular sign for a minute. So minus 2a minus 4 is equal to the square root of 10 multiplied by the square root of a squared plus 1. Is that alright? I have a modular equation. How will I get rid of that modular sign? Square both sides. So square this side, square this side. Squaring this side, square the first, 4a squared. Twice the first by the second is plus 16a. Square the last is plus 16. Over here, when you square the square root of 10, you get 10. And if you square the square root of a squared plus 1, you get a squared plus 1. Okay, multiply it out, tidy it up. So I'm going to multiply it out. That's 4a squared minus 10a squared would be minus 6xa squared. I have 16a. So I've got minus 6xa squared. Oh, for the love of God. So you minus 6a squared plus 16a, and then I have plus 16 minus 10 when it comes over, so that's a plus 6 equals 0. Divide across by a minus 2, right? A minus because I want that to be positive, and 2 because I want to simplify everything. So that's 3a squared minus 8a minus 3 equals 0. 2 sets of brackets, 3a and a, 3 and 1 and a minus and a plus. And then you let each bracket equal 0. So let each bracket equal 0, so you end up with a is equal to minus 1/3, and you get a is equal to 3. Is that okay? Happy with that? Right, number 9, you didn't have number 10.
Yeah.
Right, number 10, I had number 10 I didn't do as an example. So I meant to do one. I have number 11 marked, but I didn't get to it the last day. So I'm going to do number 10, but can you write it into your notes as example What example is next? So what was the last example we took down? 3, 2, this example 3, so. Right, okay, so example 3. So it show that where am I? Lies on the same side of the line.
Excuse me, please, could the following students come to reception now? Eva Kiley, Ellie McCarthy, Sinead McGuinness, and Ella Fitzpatrick. Thank you.
Right, okay. So you're not showing they're the same distance from the line, you're showing they're on the same side of the line as each other, right? As in, the line is here, one of the points is here, the other point is here. So they're on the same side of the line. If they were on different sides of the line, one point would be there and the other be over here somewhere. Okay? So you're just showing they're on the same side of the line. So you get the perpendicular distance from each point. Remember the origin is not naught. So you get this perpendicular distance from each point to the line. So let's do minus 2, 6 first. So it's 3 times minus 2 plus 2 times 6 minus 7 all over the square root of 3 squared plus 2 squared. Okay, and the other one is 3 times 0 plus 2 times 0 minus 7 all over the square root of 3 squared plus 2 squared again. So that would be on top, I would get, that's minus 6 plus 12 is plus 6 minus 7 is minus 1 all over root 13. Over this side, I'd get minus 7 all over root 13. Right, okay, I know the straight lines means drop the minus, but before I put the straight lines into the modular signs into play, I see that this is on the negative side, this is also on the negative side, agreed? So they're both on the negative side. So if both points are on the negative side, as in if it's negative distance to get from the point to the line, they're both on the same side of the line, job done. Because you ended up with 2 minus numbers. If I ended up with 2 positive numbers, they'd both be on the same side of the line. If I ended up with 1 minus, 1 positive, they're on opposite sides of the line. Is that okay? Does that make sense to everyone? Because I've ended up with 2 minuses, they're on the same side of the line. If I ended up with 2 pluses, they'd be on the same side of the line. If I ended up with 1 minus, 1 plus, they're on different sides of the line. Okay? Is that alright? Yes.
Since they're like homogeneous, are they going to negative then?
Because before you apply the modular sign, they're both negatives. Who am I talking to? Sorry. So it's before you apply the modular sign, you're just comparing. Okay? The length of the line from minus 2,6 to that point is plus 1 over root 13. Right? And the length of the line from that 0, 0 to that line is plus 7 over root 13. But you're just comparing, are they on the same side of the line or not? So you would just compare before you apply the modular sign. Is that okay? Yes.
There's that was in root 18.
No, that says root 13. Okay. Because 3 squared plus 2 squared is 13. Okay, I would never add wrong. Right, I'm going to do one more example of these before I move on to the next one. Can I move this up? So example 4. Right, write down parallel, write down the equation of any line parallel to the line 4x plus 3y plus 1 equals 0. And the reason you're going to do that is you're going to find the equation, hence find the equation of the two lines
Yes, what's the number before the X?
for where am I? Which are parallel. Right, okay, so I'm giving you a line and I'm saying give me the equation of two more lines that are parallel to that line and 2 units from it. Okay, so the line, just, I'm not drawing this accurately, but we'll just say that this is the line, right, okay, that I'm given. I want a line that's parallel to it at this side and it's 2 units away. So if you were to get the perpendicular distance there, it would be 2. Okay, so I want the equation of this line here, and then I also want to get a line at the other side, right, which is also 2 units away from it. Perpendicular distance is also 2, and I want the equation of that line there. Okay, is that all right? Okay, does everyone understand what I'm trying to figure out? Okay. So I want a parallel line either side of the original line that's 2 units away from it. Okay. So, and they're helping me out in the question, because first off, I have to write down the equation of any line parallel to 4x plus 3y plus 1 equals 0. Right? Okay. So basically the general equation of a parallel line, right, they have the same x. Because they have the same slope, they have the same number in front of the x. They have the same number in front of the y. Okay? And the number there at the end, that could be anything. right? Okay, so I'll just call it C, right? That can be any number. So 4x plus 3y plus 4 is parallel. 4x plus 3y minus 7 is parallel. 4x plus 3y plus absolutely anything is parallel to that line. Is that okay? Right. So the general equation of this line here is going to be 4x plus 3y plus a number equal to 0. And the equation of this line here is also going to be 4x plus 3y plus a different number equals 0. Is that okay? Right, so now I have to figure out what that number is, right? Because that's my task, right? So I need to get the perpendicular distance from this line to here and from this line to here. Agreed? Right, in order to get the perpendicular distance, I need a point, don't I? So will I get a point? I'm going to get a point on this line. See this line here? The line that I'm given, I'm going to get a point, right? So I'm going to get a point on the line for x plus 3y plus 1 equals 0. What point will I get? How will I get a point on that line? Let x equal 0. Don't let y equal 0, just let x equal 0 and you get a point. Or let y equal 0 and get a point. Or let x equal 1 and get a point. Right? Or let y equal 7 and get a point. Okay? So I'm just going to let x equal to 0. Right? Okay? So everywhere I see an x, I'm putting in a 0. So that's 4 times 0 plus 3y plus 1 equals 0. So solving there, you get y is equal to minus 1 over 3. Sorry, up. Is that it? Have I cut anyone off? So a point in that line is 0 minus 1/3. Okay, so back to my diagram. Okay, I've just got a point on the middle line. So my point on the middle line is 0 minus 1/3. I'm going to get the perpendicular distance from that point to this line, and I'm going to get the perpendicular distance from that point to this line. I know the answer is 2. Would you agree? Okay, so if I get the perpendicular distance from that point to the general equation, right, okay, the answer is going to be 2, isn't it? Okay, so everywhere, so it's the positive value of 4 times, instead of x, 0, plus 3 times the y, which is minus 1/3, plus the c, that's what I'm trying to figure out, all over the square root of 4 squared plus 3 squared. And I know the answer is going to be 2, because they told me in the question. Okay? So I know the answer is going to be 2, because they told me in the question. Yes?
Where should we put the lines on either side of the 4 to...
Because there's going to be 2 lines that are 2 units away from it. There's going to be 2 lines that are 2 units away from it. So that measure, the perpendicular distance is 2, so there's going to be 1 at each side. There's going to be exactly 1 at each side that's 2 units away.
And then in the fraction that you were just doing in the equation, so was there only lines on the top?
Because that's the formula. The lines are only at the top.
Oh, okay. But they're on-
Yeah, no, they're only at the top. Right, are we good? Right, so multiplying out on top, I'll get 4 times 0 is 0, 3 times minus 1/3 is minus 1, plus c, take the positive value, underneath the line, that would be the square root of 4 squared plus 3 squared, which is the square root of 25, which is 5. Okay, so I took a few shortcuts there, is that alright? Okay, are we all okay when I simplify out that? Cross multiply, so I'll get the positive value of minus 1 plus c is equal to 5 2s are 10. What I do now? Square both sides, modular equation, square both sides. So we have square the first, twice the first by the second, square the last. What am I doing? Yeah, I wrote it backwards at the same time. Square the first, twice the first by the second, square the last, okay, equals square that, you get 100. Okay, everything over to the left, so you get c squared minus 2c minus 1, that's plus 1, isn't it? Plus 1 minus 100 would be minus 99 equals 0. Factorize c and c, 9 and 11, a minus and a plus. So c turns out to be minus 9 and c turns out to be plus 11. So the equations are 4x plus 3y minus 9 equals 0, and the other one is 4x plus 3y plus 11 equals 0. Okay, is that alright? Okay, we're going to do one like that before we move on. Right, okay. There's no parallel lines there. Hang on a sec. Right. I'll just give you right. So you want to write down the equation of two lines that are parallel to 3x minus 4y minus 1 equals 0. So they are parallel. So I want the equation of two lines that are parallel to 3x minus 4y minus 1 equals 0, and there are 3 units from it. Okay, will you do that now, please? So I want the equation of two lines that are parallel to this, that are 3 units from it. Sorry. Yes? Yeah. Done? Here's the answers. Are we good? Are we good? Say that again?
I think the signs are opposite. Yeah, I got them.
Yeah. So it's 3x minus 4y plus c equals 0. Get the perpendicular, or get a point on that. What point did you get? Did you let x equal 0?
Yeah.
Yeah, so when you let x equal 0, you'll get y is equal to minus a quarter.
Excuse me, please. Will Grace Maloney and Victoria Stepien come to reception now, please?
So 3 times 0 minus 4 times minus a quarter plus c, positive value of that, all over the square root of 3 squared plus 4 squared. And the answer is 3. Sorting out above the line, you'll get 1 plus c all over 5 is equal to 3. Cross multiply, you'll get 1 plus c equals 15. Square both sides, so you'll get 1 plus 2c plus c squared equals 225. 225? Right, so you'll get c squared plus 2c minus 224 equals 0. And I presume it's 14 by 16 looking at the answer. So it's c and c, 14 by 16. And I want to end up with a plus and a minus. So c equals 14 and c equals minus 16. Okay, is that all right?
When you're making the formula, you put the 3x, take 4y plus c.
Yeah.
It's always going to be plus c, because you know the way
No, it doesn't matter. If you put minus c, you'll end up with c is equal to minus 14 and c is equal to plus 16, and then when you put minus c into the equation, you'll end up with plus 14 minus 16. So it actually doesn't matter whether you put a plus or a minus.
Miss, is that not just 2 units?
Sorry?
Is that not just 2? Or is the 1 over 4? Did you not have to get like 3?
3, yeah, I did. Equals 3. Equals 3. And 5 3s are 15.
Oh, so 15, 14, or minus 16?
Yeah, no, 15 has nothing got to do with it. The 15 is just when I cross multiplied, that's what I ended up with.
But you know, the way for the other one, you got 2 units and then you got minus 9 plus 11.
Yeah.
Are they not 2 units? So do you not have to get like 3?
No,
Oh,
that
three
was
is what you used.
that was just a freak accident.
Okay.
Right, okay? Coincidence. Right. Are we good? Right. Before I move on to the next section, right, okay, I just want to make sure you know the general equation of a parallel line, or so we know a parallel line. What about a perpendicular line? So it's the exact same method, but you just have to know the general equation of a perpendicular line. So if I have a line 3x minus 4y minus 1 equals 0, which I just did have. So I'm not doing another example, right? Okay, but a parallel line, you've just told me, will have the form 3x minus 4y plus c equals 0. Agreed? Right, okay. A perpendicular line. Right, a perpendicular line will have the general equation. Right, remember, the slope of this is minus 3 over minus 4, agreed? Minus a over b, which is 3 over 4, yeah? So the slope of a perpendicular line would be minus 4 over 3, wouldn't it? Okay, so that would be a 4 in front of the x, and what am I after doing there now? And 4, that's minus a over b, so it's minus 4 over 3, so there's a 4 in front of the x and a 3 in front of the y. Agreed? So look, for perpendicular lines, you swap the a and b and you change the sign of the y. Okay? So swap the a and b, so swap the 3 and the 4 and change the sign of the y, and you get a perpendicular line. Okay? So for example, if I have a line x plus 2y minus 4 equals 0. A parallel line would have the same x coordinate and y coordinate, so it would be x plus 2y plus a random number equals 0. Agreed? What about a perpendicular line? Swap there's a 1 here and a 2 here, so swap those. So that would be 2x, change the sign of the y and put the 1 in front of the y. Okay, plus c equals 0. Do you all see what I've done? Okay, if I just make up another line, 5x minus 3y minus 1 equals 0. Parallel line, 5x minus 3y plus c equals 0. Perpendicular line, tell me. 3x, opposite sign, plus, put the 5 in front of the y, plus 5y plus c equals 0. Right? Okay, one more. If I have 3x plus y minus 2 equals 0. Parallel line, 3x plus y plus c equals 0. Perpendicular line. Swap the a and b, as in the coordinates or the coefficients of x and y, swap those and change the sign of the y. So what will I get? 1x sine minus 3y plus c equals 0. Because there's a few questions there with perpendicular lines where you have to get the equation of a perpendicular line. So you just get the general form and then it's the exact same way. Find a point on the original line and then let the perpendicular distance equal to whatever. Is that alright? Are we good with that? The general form of a perpendicular line. General form of a parallel line. General form of a perpendicular line. Okay, can I move on to the next section? Right, okay. What movie are they watching? Have you figured it out? Do you hear the movie? No. I don't know what one they're watching. Okay. Okay, so the next section is the angle between two lines. So the angle between two lines. So if you have one line and you have another line, they make angles, don't they? They make 4 angles, right? 2 sets, as in this one would be equal to this one and this one would be equal to this one. Agreed? Right, okay. So when two lines intersect, they make, when two lines intersect, they make two angles, two distinct angles, right? Obviously there's 4 angles, but it's 2 pairs, 2 angles, an acute angle and an obtuse angle. What's acute mean? Less than 90. And acute means somewhere between, obtuse means somewhere between 90 and 180, and an obtuse angle. So when two lines intersect, they make 4 angles, 2 pairs of angles, 2 pairs, and a pair of acute and acute angle and a pair of an obtuse angle. Yeah, is that okay? Right, okay. And tan of theta, right? Okay, and you can call any of these. Theta is just a Greek letter, like A, B, C, X, Y, whatever. Okay. Mathematicians love Greek letters because lots of maths came from Greece. Plus minus m1 minus m2 all over 1 plus m1 multiplied by m2. Okay? What does m stand for? Slope. Right? So the tan of the angle that they make, plus minus. So one of them is going to give you, there's going to be 2 answers, isn't there? There's going to be an acute angle and there's going to be an obtuse angle. Would you agree? There's where the plus minus come from, because there's 2 sizes of angles there. Agreed? So there's 2 sizes of angles there. So that's why I'm getting a plus or a minus. There's 2 angles, so 2 answers. Okay? M1 is the slope of one line. M2 is the slope of the other line. So you subtract the slopes on top, you multiply them on the bottom, and then you get the inverse 10 to find out the angle. Okay? Again, this formula is in the log tables, right? Okay, it's the last formula you have to know about. Okay, so example 1. Find the value yeah. Measure, yeah. Find the measure of the acute angle between x plus 2y plus 1 plus 4 equals 0 and x minus 3y plus 2 equals 0. So I'll be asking you in a minute to remember back to some of your junior cert trigonometry. Okay, it's easy enough, but anyway. So what do I need? Looking at the formula, what do I need from each line? Slope. So I need the slope from each line. Doesn't matter which one you call M1 or M2. No. Right, so there's this line. Here's this line. Get the slope. So the slope M1 is minus A over B. Very handy formula, not in the log tables, minus A over B. So minus 1 over 2. Agreed? M2 is the slope of this line. Again, it's minus A over B, where A is the number in front of X, B is the number in front of Y. So it's minus 1 over minus 3, which is plus 1/3. Okay, so M1 is minus a half, M2 is 1/3. Right, are we good? Right, okay, so tan of theta is equal to plus minus. Now they've only asked for the acute angle. I'll deal with that in a minute. Okay, I'm just going to get both angles, right? But so it's M1 minus M2 all over 1 plus M1, which is minus a half, multiplied by M2, which is 1/3. That's minus a half there. Got skewed a bit. Yes.
You know when you let like M1 and M2 equal the minus A over B,
Yeah?
how did you know that it was a minus and not a plus?
That's in the formula.
Oh,
It's part of the formula. The minus is part of the formula. That's the shortcut to getting the slope from the equation. In junior cert we would have rearranged so we have y equals mx plus c. So the y term equals everything on the left, and then we would have read off the number in front of the x. This is the shortcut. Okay, so the minus is part of the formula, and that formula is not in the log table. It's that minus a over b. Okay, so if you want to use it, you need to remember it. Do you need to remember it? No, because you have another way, but it's longer. Okay, so tan theta into the calculator. Just leave out the plus minus a minute, right? Just put the whole lot of that into the calculator, and that's minus a half minus that would be minus 5 over 6. I'm just doing it out by hand because by the time I type it into my calculator, that's over 5, 6. That would be minus 1. Okay, so is it minus 1? It does work out to be minus 1, I think. So tan theta equals plus minus minus 1. Okay, yeah? So one answer is tan theta is equal to plus times minus 1, which is plus 1. And the other answer is tan theta is equal to minus times minus 1. One is going to give you an acute angle, one is going to give you an obtuse angle. Yeah?
what does it say under the 1 plus? Yeah, what
1 plus minus a half
do it?
minus 5 over 6 all over 5 over 6. You don't even have to write that line because you're going to do all that in the calculator. Okay? Right, okay, so tan theta is equal to plus 1 and tan theta is equal to minus 1. Right, does anyone remember, if you know tan of the angle, how do you get the angle? So I know the answer. If I go tan of whatever angle and I press equals, when the answer is 1, does anyone remember how to get the angle? Shift. Yeah, you go shift, tan and 1. Right? Okay, so shift tan and 1, it means what angle has a tan of 1? Right, and the angle that has a tan of 1 is 45 degrees, I think. And if you look at the angle that has, so here you go shift tan minus 1, and you get 135 degrees. Yeah. Say that again. Minus 45, which is 135. Just go with it. Right, okay. If you get to 45, minus 45 means it's actually 330. Yeah. The thing is, the best thing to do is once you get the acute one, right, take it from 180 to get the obtuse one. It's the easiest because we'll be dealing with all those minuses when we get onto trig. Okay, yes.
Why is it like for the first tan theta equals plus minus 1?
Yeah, you know it's plus.
So just the line below that there, like when you're multiplying the plus
Y-
and stuff.
Plus by a minus is a minus, isn't it?
Yeah.
So that should be that. Right, okay, and this one should be a plus. Right, either way, you still get 40. Sorry, I just wrote them in the wrong order. Right, so we still have 45, if you just get the acute angle and subtract it from 180 to get the obtuse angle, right, that'll do, because with trigonometry there's lots of messing around with minuses and pluses that we understand completely when we do trigonometry. But for the moment, get the acute angle and subtract it from 180 to get the obtuse angle. Does that make sense to everyone? Right, we'll deal with all the minuses and the pluses when we get on to trig. Is that alright? Okay. Questions? Yes. Yes.
Would you know when you put shift tan minus 1, are you supposed to get 135?
No, you'll get minus 45, I believe. Yeah, which is messing around with trigonometry. So I'm saying just get the 45 and subtract it from 180 to get the 135. Because if you go back to my diagram, right, if you're getting the angle between two lines, if the acute one turns out to be 45, the obtuse